So like William said, my name is Kristin-Tufte. I'm a prof here in computer science and civil engineering. And I am a research prof, which means I do mostly research and projects, and I teach occasionally. Let's see. Other things you should know about me is I'm a total coffee addict. I'm absolutely convinced that Starbucks would go under if it weren't for me. And I have two boys, 14 and 16, who are the lights of my life. So today we're going to talk about Portal. And so the talk really has three parts. The first part of the talk I called Bling and Data Sources. And the second part of the talk I called The Devil is in the Details. And the third part of the talk is sort of about some of the communication and political issues I've ran into running this project. So first of all, what is Portal? So Portal is a transportation data archive. There's about 2 terabytes of transportation data. We have all sorts of data. If there's a type of transportation data in Portland, Vancouver, I probably have a sample of it. So tons and tons of data. Tons of really interesting data that lives in a Postgres database. It's supported here by the cat, and that's why I'm here today, because when the person who keeps your servers alive asks if you want to give a talk, you just say yes, when, and I will be there. Tell me I'm wrong, right? Yeah, because if I'm not here, you know, and I was a little bit late on like the abstract, you know, I worry about like my servers crashing at random inopportune times, such as in the middle of the demo. So anyway, it's a about 2 terabyte transportation database, but we just bought like another 20 or 30 terabytes of storage, so we're expecting it to grow significantly because there's a bunch of data that I've been holding off on because of storage limitations. So there's a transportation data archive in Postgres, and then on top of that there's a website. And the website has some nice bling and some nice pictures, and I'll show you some of that. But I also really want to talk a lot about the data, because for me the really interesting part of this project is learning about the data sources, learning about the hardware and the software, and some of the complexities involved in trying to get data from these sensors out in the Portland, Vancouver area back into our little database living here. Okay, just for fun, this is the Portal homepage, and this is showing live traffic speeds. So if you were out on the freeways right now, this is what you would be experiencing. You can see this is I-5 coming into downtown. It's red. 84 is always a mess. And also, if you live in Vancouver, this is your big problem until they get that bridge fixed. So we also have an archive. We have this freeway data goes back to like 2004. So this is supposed to be sort of average traffic in Portland. So this is a 15-minute average speed over the last 5 weekdays. And if you compare the current map to the previous map, you'll see things look much more red and orange today than on average. So today's a bad traffic day. So it's a good thing you're here instead of sitting in traffic. Okay. So just keep an eye on the time. Okay, so first part, Bling and data sources. And throughout the day today, I'm going to talk about 3 different types of data: freeway data, arterial data, and transit data. So the first 2 sections will have a little bit on each of those. So freeway data. The data archive started in 2004 with Freeway Data. We get a live feed from the Oregon Department of Transportation and from the Washington Department of Transportation. It's updated every 20 seconds with speeds at each one of these locations. So each dot, can you guys see that, or is that, do you see it? Okay, I want the lights on so I can write on the whiteboards also. So each of these spots represents a detection location, and every 20 seconds we get speed and volume and occupancy from each of these locations. Occupancy is not the number of people in the car, it's something else. You can click on a location, Terwilliger Boulevard, you get a detailed map, and then we get this nice little plot that shows speed and volume at this location so far today. This is speed. You can see the speed at Terwilliger Boulevard drops in the morning. So at 8 o'clock, the average speed there is about 30 miles an hour. This is my commute in the morning, so that always causes me a lot of mess. And you can see now, again, the speed is dropping in the evening commute. So there's a lot of options here. You can pick a start date, a time. You can have different resolutions and create all sorts of funky graphs. The purpose of these graphs is twofold. One purpose, so the website is really developed for the local transportation agencies. That means ODOT, Metro, City of Portland, TriMet. And so these plots give the people who work at those agencies the ability to come in and browse through the data, figure out what data they want, and download it. We also use plots and periodically generate reports with it. Okay, so this is some JavaScript on top of PHP on top of a database. We all kind of know what that is. But what's more interesting is maybe where these data comes from. So this is Freeway Data. So each of these data comes from these inductive loop detectors. And so here's a highway, and this one has 2 lanes. And there's an on-ramp. And at every single on-ramp in the city of Portland, there are loop detectors that sit here. They're typically placed just before the on-ramp. And there's 2 of these. And these are, like if you go to a stoplight, and when you sit in front of the stoplight, like there's that, you can sort of see that circle of metal. Okay, that's what these are. So it's a circle of metal, and it has the ability to detect whether a car is there or not.
Or not with motorcycles. They hate them.
No, they don't do so well with motorcycles. They also don't do so well when cars drive down the center of the highway. And there's a lot, one of the fun things about this is I get to work with all these local agencies, so I get to hear all the stories. So this is supposed to say this later in the talk, but we do these projects, and then we're trying to analyze the data, and they say, oh, well, you know what? All the data for I-5 at Terwilliger is missing, and what's going on? And invariably, the answer is like, well, somebody drove their car into the cabinet, and it took out 3 loops, or one time we had somebody who stole all the copper from a cabinet or 2, and so we had no data because all the copper got ripped off. I mean, it's always something. One time, okay, I'll tell that story in a second. Okay, so what's sitting here is these 2 wires, and then they feed back to this like cabinet thing. Like those big silver cabinets are about like this tall. They're on the side of the road. So the wires feed back into here, and there's a computer. There's a a card in here that amplifies a signal, and a computer in there that is approximately from 1920 or so, and then the feed goes back to ODOT. Okay, so actually maybe it's a little newer than 1920, but I tell you they are not new. They're really like from the 70s or so. So when a vehicle drives over this, we do 3 things. One, we can count the vehicles going over. We can also get the speed of the vehicle, and then we get something called occupancy, which tells you the percentage of time that somebody's over the loop. So those 3 data things are fed back to ODOT, and then we get a feed of that data directly into Portal, and then it's used to create these plots. So the type of detectors we have in Oregon are all these loops. And does anybody know why they always put 2 loops down? Does anybody know why? Make a guess? Direction. What? Not direction. No, because it's a freeway. You're not supposed to be going the wrong way. Although it would be interesting, because actually we have wondered that, like, if we saw like negative speed. Okay.
Air control?
Nope. Yeah, why speed? Right. You use 2 you check. So if I just had 1, I could easily count, right? Here comes a car, here comes a car, here comes a car. What each one of these does is they give it sort of a, it's not quite on off, but here's a car, and here's another car. So you say, when does this one go on, and then when does this one go on, and you can tell the speed difference with 2. So when you have 2, you can get an accurate reading of speed. If you just have 1, you can estimate speed, but it's really inaccurate. This is what we use in Oregon. Washington uses a lot of stuff a new type of detector is this high definition radar, and it sort of sits on the side of the road, and it beams radar across the road, and it can grab like 6 lanes of data. And those are the new detectors that are kind of getting put in. Most of them are in Washington, and they're putting some here in.
Do you know what frequency they operate on?
No, but the vendor is Wavetronics. The best vendor is called Wavetronics. I bet their website would. I don't know.
Probably 60 gigahertz or something.
You can Google. No, I don't know. I just know they're the cool things that sit on the side of the road and gather the data. So they also have, the other thing that's in here is there's loops on the on-ramps. And so cars can drive up to these loops. And you know, there's the little traffic lights here, right? And so the traffic lights are actually controlled by a dynamic algorithm that takes the data from the loop detectors all along the freeway and determines whether it should let cars on the freeway or not. One really interesting other problem we had was at one point these on-ramps got, one time they got wired wrong. And but then the interesting thing was they couldn't go out and fix it because Oregon is so rainy, and they had to wait until we had dry pavement to fix the change. So, you know, we had to wait 6 months without data from one station because it was raining and it couldn't be fixed. Third type of freeway data that we have is Inrix. So have you guys heard of this company called Inrix? It's a Microsoft spinoff. And they have contracts with like all the trucking vendors and the taxi cab vendors. They won't tell you exactly who, but they have vendors with contracts with a lot of the big vendors. And you know, all the taxis and all the trucks, they have GPS units in their vehicles these days. So the GPS pings go back to the trucking company, and the trucking company sends that data anonymized to Inrix, and then Inrix makes traffic speed data out of that information. So that the big selling point of that data is that it's on the freeways and on the local streets, and in addition, the data doesn't require the installation or maintenance of physical detectors. Okay, so that's something about the freeway data. Next data is data source is arterial data. So what's an arterial? Anybody know?
Major street.
Major street, but what? Main through street for residential, close. Yeah, so it's a main street that's not a freeway. So the big difference from a transportation perspective between an arterial and a freeway is the arterials are called interrupted flow. That means they're stoplights. So on a freeway, you just keep going unless you hit stop and go traffic, but there's none of these break points. So on arterials, the big difference is they're stoplights, so the cars don't move freely. So from our perspective, it maybe doesn't make that much of a difference, but from a transportation engineering perspective, it does make a lot of difference. Okay, so let's see. Does it work? I should pick something in the date range that we put up there for that purpose, shouldn't I? So this is something you notice. There's this line right here that says the station has data available from 2011 through July 2012. So this is what I'm talking about a little bit in the next time, is that actually, you know, getting this data from these detectors and from these systems back to the database is much, much more difficult than I would have ever expected. So this is just a similar plot. This is speed and volume on St. John's Road at 88th Street up in Vancouver. And the detector sitting at these locations is one of these fancy Wavetronics side-fire radar detectors. So we have a couple of types of data that we get on the city streets. One type of data is this speed and volume data that's really similar to the freeway data. Another type of data that we get is Bluetooth data. or travel time data. So calculating, I'm not going to explain the details. Calculating travels on the freeways you could do with spot speeds, but you can't calculate travel times on the arterials with spot speeds because of this whole interrupted flow issue. So if we want to find travel times on arterial, where's the eraser? Somebody take the eraser.
Maybe behind the screen?
I put it right there. It's my fault. So I was teaching this course once, and about halfway through the course, there were like no whiteboard markers left in the classroom, and I was so frustrated and so annoyed. Who on earth is taking all those whiteboard markers from the classroom? I was really annoyed.
Other classrooms where they run out.
Oh
They
no,
go
then
and grab
I
them.
go back to my office and I look at the whiteboard in my office, which is just overflowing with whiteboard markers. So at midnight, I snuck the whiteboard markers back into the classroom. Okay, so like I said, we can calculate travel time on the freeways using these detectors, but we can't do that on arterials. So what they do on arterials is they do this. They put a little Bluetooth reader, and yes, this reads the MAC address off your cell phone or off your Bluetooth headset or whatever Bluetooth device you may have in your car, your kids' Game Boy or whatever they have right now. So what we get is a list of MAC addresses at this location. You know, and maybe there's some side streets here and a stoplight here. So we get a list of MAC addresses at this location and a list of MAC addresses at this location. And then you match them up with some sort of fancy matching algorithm. And then that will give you travel time from location A to location, yeah.
I was hearing that they also do that kind of traffic analysis with cell phone signals from towers.
At one point in time, they did try and do this type of analysis with signals from cell towers. I heard a bunch about that maybe 3 years ago. I've not heard much about it recently. This seems to be the new.
It seems like it'd be hard with a cell phone, but this is much more localized
Right.
data source, so much easier.
The problem with the cell phone tower was it was harder to figure out exactly where the vehicle was. In this case, you know where the vehicle is. The problems here are that somebody can be at location A and then stop at Starbucks right here and then drive to location B, so that their trip actually takes an hour when the travel time is really 10 minutes. So when you do the matching process, you
Plus you have to get an electronic box for every location you want data kind of thing.
and you do have to get an electronic box at every location you want data. And they're really cool. These little Bluetooth readers, they're like this big, and they have these, you know, they have those little itty bitty cards that run, and they run Linux, and they have like little Python or whatever scripts on them that do the processing. So I should say that we truncate the MAC addresses at the readers. So the MAC addresses are truncated or otherwise anonymized at the reader, so the data that we get back is not associated. You can't associate it with a person. Okay, so of course we have funky graphs for that too. And you see here that I'm going back into like 2012 to show you some of these plots. And like I said, that's an issue with grabbing the data that is just way more difficult than you think it should be. Whoops. You have to select a start station. So I want to find out data from Powell and 8th to Powell and 54th. And so this is travel time from Powell and 8th to Powell and 54th on November 1st. So this data looks a little funky. I don't know what this is, but this is the morning peak, and then this is the travel time increases as people are going home in the evening. So about 300 seconds normally, and up to almost 700 seconds.
That's probably when people go home from bars. That's at 2
Oh, is it
o'clock.
2 o'clock?
That's at 2 a.m. So.
No.
No, the one on the left.
Oh, this is the bar traffic. Yeah, but you wouldn't think they would, that's somebody driving really, you know, this could be just one data point. Or, you know, I don't know what's going on there. Yeah. Yeah, I wouldn't think there'd be that much traffic at 2 in the morning, though.
Yeah, well.
Yeah, just really slow traffic. So it's another data source. Yeah. How do we get the data from the Bluetooth boxes? So each little Bluetooth box runs a little Linux computer, and there's a server that sits at the city of Portland. And when we want to retrieve data from those boxes, they're batch scripts that are
No, I meant, are they wired lines, or is it wireless, or?
wired lines.
Oh, okay.
Yeah, everything is
So
wired.
a modem kind of thing for that, a low? It just seems like they're running a broadband connection out. That's what I was thinking before about how it's hard that the box is easy putting out there. It's getting the power and data connections to each location you want to grab data. So maybe they just take advantage of ones that already have that kind of thing there.
So that's an excellent observation. And what you said at the end is exactly what they do. So you know, what he's making the comment is you can easily make one of these little Linux box that does, that reads the Bluetooth addresses. Probably could do that and put it out in front of your house in case you were curious. Or, but getting the data back is difficult. And this is difficult with all the sensors. You need power and you need connectivity. And so we're limited in the places where we put these. We try and put them by existing signal boxes. So the traffic signals in Portland all have the cabinets, and those typically have connections back to the city of Portland. And those even, they have two-way connections. They can sit at the city of Portland and make changes to those, or Clark County, they can sit and make changes to their signals from their desks. So you look for locations with power and internet, and that's where you're going to put them in. Okay. Third kind of data I'm going to talk about is transit data.
I actually have a question about this.
Yeah.
Data. Since you guys are just using Bluetooth readers, how would you like filter out something like vibration?
So there's a matching process, and
I mean, I imagine you need contact as well.
Like a bicycle.
yeah, so a bicycle will get caught, or somebody who stops and pulls over for a little bit or stops to buy something will get caught. So the matching process filters out that. So they
Maybe throw away the length of time that it takes to get from one to the other if it's too long.
Like the interval's too long, it throws it out type of thing.
So if most of the traffic going through is going through in, say, 2 minutes, and then you see something come through in 5 minutes, you consider that an outlier, and you toss it out. So it tosses out stuff that's outside of the current norm. It's a little bit tricky because you have to be careful when you toss out stuff if you toss out too much stuff, you don't catch the changes. But you know, typically bikes are so much slower than cars that you can toss them out. Yeah, what I think would be really interesting is to take the data, and you would assume that the data kind of has two bumps: a bike travel time, which is very slow, and then a car travel time, which is faster. It would be interesting if you could get both out of there. But so far we focus on just getting the vehicle travel times. Other questions? You're free to interrupt me at any time. Okay. Transit data is just cool. This is just a funky map so Morgan Harvey, I should give credit, he does the vast majority of the programming on Portal, and he has something like either dengue fever or Ebola or possibly the flu, so he's not around today, but he's done a phenomenal job with the programming. So he made this cool transit map. So the buses collect so much data. Do you guys know this? Amazing amounts of data. They have counters on there. Every time they go past a stop, they get the time they went past the stop, the maximum speed the bus reached before the previous stop, how long they stayed at that stop, the time they left they stopped, how many people got on, how many people got off because they got little counters on the bus, did the lift go down, did the lift go up. So they collect just huge. TriMet has so much data you can't even imagine. So they collect enormous amounts of data. So we're trying to do some visualizations for them. And we're really starting on this work. We haven't done a lot of work on it, so this is pretty simple. This is just showing performance on a stop level. So each dot here is a bus stop, And and right now I have them colored on, I think I have them colored on load. Yeah, so this is average loads. This is TriMet second quarter of 2012. So this is the average number of, they're colored by load, and load means the number of people on the bus at that stop. So stops that are darker and larger have more people, and stops that are smaller and lighter have less people. That's what this map means. We're working on creating some more line-based maps. This is just a point-based map, but we want to create some speed maps for the transit data. Okay. Okay, so that's sort of the portal front page and a few of the types of data that we have in portal. I wanted to spend a little time talking about the section that I called the devils in the details. And one thing I learned is getting this data, it's, you know, you just always run into these problems. And I always like it, I take the transportation data back to the computer science people and they look at the data and they're like, there's a missing data point. I'm like, yeah, it happens and we gotta figure out how to deal with it. So, like I said, all sorts of crazy things happen. And the freeway system, we had, you know, people crash into the detectors. And another thing I'm doing is I'm merging data from both Oregon and Washington. And so one issue I ran into there, on the freeway data, we're getting the exact same type of data. It's speed, volume, and occupancy from Oregon and from Washington. But the Washington people identify their detectors with strings, and the Oregon people identify their detectors with integers. So there's all these sort of small little problems, like putting the, yeah, the strings are not my favorite, but it's what they do, and they have a reason for it, and it's the way it's been like that forever. And to change it means a huge change to their system, so we have to figure out how to convert their strings into integers that we use in the system. Let me just take a second here and check myself on time. I know. I've got, well, I'm not going to take a whole nother hour, I don't think. Okay. A couple of data quality issues we had with the highway data. We had a lot of issues on, we had a lot of low overnight speeds. So we would look at the readings and we get a lot of zeros overnight. And so we went out and we actually put on hard hats and went out to those cabinets and looked at that, and we found some really interesting issues. So it turned out when we went up to some of the cabinets, there were actually some configuration issues in the cabinets, and that fixed some of the problems. And there were also some crosstalk issues where, you know, the wires are coming off the road and they go into these loop amps, and if you don't wire them up exactly right, then there's two wires that are right next to each other, and the signal from this wire trips off the signal from this wire. Always. And overnight, when there's not very many cars going by, you can get lots of these types of issues. One thing that is a couple things that are going on the freeways in Oregon right now that are pretty cool. There are two things that are going on. So one thing is, about 5 years ago, I did a travel time study, and it was 5 years ago, so we didn't all have iPhones then. So we sent people onto the freeways with these little GPS devices, and we just had them sort of drive loops on certain segments of freeways, and they measured actually how long it took them to drive on those freeways, and then we compared their travel times to the travel times that we calculated from the system to just see how accurate the travel times were. We didn't actually think the travel times would be very accurate, but they turned out to be pretty good. Most of them were within 10%. And what we found out is that travel times were really inaccurate. There's portions of Portland, like the Fremont Bridge right here, where there's no detection. So all the detection in Portland was installed where there's an on-ramp. So if you drive I-5, there's an on-ramp here at Arterial Boulevard, and then there's a long way through here where there's not very many on-ramps. And so there's huge sections of freeway where there's no detection at all. And The Fremont Bridge is one of them. The Fremont Bridge is often congested. And if you're trying to calculate travel times without any information about these severely congested areas, you're going to get crappy travel times. So a big result of our study was like, hey, you can't really put travel times out for the whole Portland area until you fill in some of this detection. So ODOT recently got a whole bunch of money, and they've got about 100 new of these cool Wavetronus detectors that they're putting out and on these areas that didn't have much detection. So that was kind of cool. Another thing they're doing in Portland, I'm not involved in this, but they're putting, do you know they're putting in variable speed limits? So this portion of I-5 coming south and this portion of 405 is going to go to a variable speed limit zone. So there are going to be signs posted that say the current speed limit is 40 miles an hour. And then you're supposed to go 40 miles an hour.
For those new detectors, it seems weird. It's going to be hard to stick them on the bridges because they don't have the travel boxes for freeway ramps that naturally hook up to. Maybe they can work out something, or if they have
They're going to, yeah, I don't know exactly. They're going to have to wire up. Yeah, but that's part of it. They're going to have to wire up the bridges. But they're probably doing, but they need them there because they're doing the variable speed limits. So they're just going to have to wire it and be done with it. So why would you even think about doing variable speed limits? So here's the question. What is the best speed? What's the speed? You know this answer, so you don't get to say. What's the speed at which you get the most traffic flow through a location? 55. You want to get the most vehicles through a particular location. What speed should you have those cars go?
Some constant one.
Does it depend on the density of the cars?
Well, it would be a derivative.
At a certain point, people will start not being able to react to things very well, and you get people slamming on the brakes, and that causes a chain reaction, doesn't it?
Yeah.
You get that coordinating.
Right. So that's part of it. Density of cars is another clue. Right.
Visibility and
Yeah,
bunch of
so
factors.
the answer is something like 40, 45 miles an hour. At 50, 60 miles an hour, the cars are more widely spaced. You have to leave yourself stopping distance. And obviously at like 20 and 30 miles an hour, everybody's moving so slow that you just don't get much flow through there. So, yeah.
Also mergers, people don't merge properly.
And, yeah. Yeah, and the design here is, also the design of this freeway is not ideal. If they had to redo it, they would redesign the merges are kind of weird. There's like right merges and stuff. But even if there's no merges, everything, if you want to get cars through a particular location, you want to go like 45 miles an hour. So they put in variable speed limits. The idea is when congestion starts to build, they slow everybody down. That increases the flow of traffic through and maybe will prevent congestion from happening. And also will prevent, hopefully, some accidents from happening, improve safety. Okay. On the arterial data, so we talked about getting counts in the arterial systems. So I've worked with 3. So the way it works is there's a signal, a traffic signal, and then there's a cabinet on the side of the traffic signal, and then there's fiber that goes back to the city of Portland or Clark County. And so we're trying here to get data from the city of Portland and Clark County, and it turns out that we've got 3 of these different signal server systems. So the traffic signals go back to 3 different types of signal server systems. And and that's complicated for us. One of the signal server systems still stores its data in files. So we just grab the files and load those into a database. The other 2 actually store their data in a database. We tried querying the database directly, but the schema's a mess, so that didn't work. One of them, we are going to end up paying the vendor to produce a feed for us because we can't get the data we want out. And the third one, actually it has enough report generation capability that we're able to generate reports, take the output of the reports, and load it into the database. Ideally, at the end of the day, I would like an automated feed so that each one of these systems just dumps its data to some location and we get that data directly without having to do all the human creating the report and humans grabbing the files. It's something we're working towards, but it typically involves having these signal vendors rewrite parts of their software, and that's time-consuming and expensive. Okay. One thing we're working on right now is creating some transit maps. There we go. Do you suppose the people at Microsoft change the slideshow button on PowerPoint like with every release just to see how many people they can confuse? They're just
That's too rational and approach.
they're just sitting up there in Seattle and they're like, yeah, if we change this, then people will get confused and they'll be embarrassed and that type of thing.
Rational.
They might be. Are these the lights over here?
Yeah, we can put some.
Oops. Leave some on.
Yeah,
Okay.
that and the side one over there, and you have enough light there.
This is plenty good. Okay, so this is a sample. We're trying to create some line-based maps for the TriMet data. So this is showing average load on TriMet lines. So darker is more writers and yellow is less writers. So some of the really interesting problems we're facing with this is that there's two things that really get in our way. One is that they change the bus schedules so often you can't even, okay, people who ride the bus must know this. I did not realize this. They change the bus schedules all the time. So that means that if I want to compare last week to this week, and I've got a schedule change in the middle, and maybe I just want to do a delta, it's not obvious at all how to do that. The other thing is there are locations, like on the Hawthorne Bridge, and the bus routes overlap, right? But maybe this is one route and this is another. So there's really three segments here. This is one bus, this is another bus, and this is a third bus. So it's simplistic to see the problem, but in terms of technical details and figure out exactly how are we going to write the queries and how are we going to store the data and how are we going to create all these GIS segments to display that data on the map, it's complicated. And we can't just go through and create the GIS segments once because the routes are going to change next week. So we have to have some way to figure out how to create these GIS segments. Okay. In terms of what have I learned, the process I go through in this, I have a pretty standard process. First step, I always just get a sample of the data. And then I find that it's really useful to work on the visualizations of the data and understanding the data in parallel with trying to get the transfer process going. Getting the transfer process going, at the university we're really lucky. All our servers are open, we can get access to any server we want. But in this situation I'm working with a lot of the city agencies, and they are, their IT departments are defensive, and so sometimes it's really difficult to get access to the machines that you want to get access to. Okay. I just want to spend maybe 10 minutes talking about this last part. This is part of a talk I gave last summer. So our goal is to take data and turn it into information. And so we have sensors in the field. We're going to bring them into our archive, and then we're going to create performance reports or something that's useful to these local transportation agencies. Really this shouldn't be that hard. I've got the data, I've got a database, it can run any query that I want, and I just need to produce some reports. So why is this even difficult? And it's, sort of, for me, being a computer science geek, it's been way, way more difficult than I imagined. Because I think whatever, you take data and you make plots and then you're good. But I think it's really a communication issue. So we're sitting over here, we're the computer scientists and the programmers. And then there's the people over there who are the users. And it took me a while to figure out that the users don't even always understand. I didn't even realize this for a while. There's multiple versions of the users. There are the operations users and the planners and modelers, and they don't even always understand what the other side is doing. So there's a large communication gap. And we're not known for our communication skills. And language is really interesting. And the scariest, and you got to watch out for this, is words that you thought you know. Those are absolutely the worst. When you both use the word visualization and you mean two utterly different things, you think that you're talking about the same thing, and you absolutely aren't. And I think that's when I learned in my personal life. First, when I said, oh yeah, I'm having a party, and then to me a party is, okay, we have 6 people over for dinner, but that's not everybody else's definition of a party. So I would just say when you're talking with users, just be really careful about language. If you don't know a word, you can ask, but then be careful about those words that are actually being used in 2 different ways. Here's another thing I thought about. For me, I've got all this data, and I can make a million different plots from this, right? We can twist the data that way, twist the data this way. But of those plots that I can come up with, probably only 3 are useful to the users. So the process of going back and forth between myself and the users and trying for me to say, here are some possibilities, and them to give me feedback on what they want and desire, that has been an interesting and useful process, because they come at the data from such a different angle, and they don't understand what is technically easy and what is technically difficult. And so to connect what's technically feasible with what's something that is usable for the users is an interesting and iterative process. So here's an example. We had this picture that I'm showing here is a result of maybe a series of 3 meetings with many people, with maybe 10 people involved in the meeting. So we were trying to just look at this data or this interface and figure out what might be useful changes to it. And there's 3 circled arrows here. So so this is a 2 quantity plot, speed versus volume at Terwilliger Boulevard, my favorite intersection. And what's circled in the 3 circles is stuff that was new, that was added as a result with the interactions of the users. And I'm talking like 3 meetings, 10 people, a lot of person hours. We had a start and an end date, always. But one thing they wanted is the ability to select certain days of the week. So I want only Monday through Friday data, or I want only Tuesday, Wednesday, Thursday data, or I want only Sunday data. So this box gives you the ability, you can imagine you click on Sunday and you get Sunday data. You can turn on Monday, Tuesday, Wednesday, and you get Monday, Tuesday, Wednesday data. That was one change. Another change is we allowed the resolution to go above an hour. So we added day, month, and year resolution. Then we had this really cool button here, which allows you to navigate upstream and downstream. So when you're doing analysis, you might want to look at Terwilliger Boulevard, and then you might want to look at the next location down the highway, and then the next location down the highway. So these buttons, yeah.
Do you do any measurements for the users, which features they actually use and how often, kind of thing?
We've not done that yet. I would love to. I don't have the budget for that.
Sure.
So you can easily navigate upstream and downstream, and this makes these plots much more useful. And when we put these plots in, and I went back to this page, I was like, wow, it made it huge, very, very useful. And now you can imagine the amount of programming time, and I won't say aloud how much programming time these buttons took. It's not very much, right? These are really, really, really simple interface changes, but they make an enormous difference to the user. But it took us a series of several meetings to get to the point where we found these changes. Another lesson I learned, and this is to all of us because I'm not sure we're good at that, be okay with simple. So this is something we put up for CTRAN. This is called transit route buffers. So this is Route 2 in Vancouver, and this is a buffer that goes like a half mile, maybe a quarter mile. The bus line goes in here, and the buffer is a quarter mile or so around the outside of the transit line. Now these buffers are interesting because developers, when they come in to build a house or a new store, they want to know where the transit route buffers are, where the transit lines go. And so C-Tran regularly gets requests from developers, give me this information about the transit lines. And if we just simply put it on our website, this is static information, it doesn't change, you just put it in PostGIS and put it on a map. This is very useful because it offloads requests off C-Tran. Yeah?
Does a buffer mean that there's extra lines going away from
No,
that?
this is just space around, just shows the general area served by that transit route.
I was wondering why it's all against the line, the freeway line. It's all to the left of that.
The transit route must go up, it's a bus route, so it goes up.
In the middle of that
In the
blank
middle of
area?
that, mhm.
Okay, so
Yeah.
there's a line going through there that we don't see. Okay.
Right. So, okay. Okay. So, so I just want to tell you a little bit about Portal, about the type of data we have in here. There's much more data than I actually talked about, but those are three sort of the main types. To give you a flavor of where the data comes from and what some of the complexities are that we've faced in pulling this data into the archive and making it available to the local agencies.
Questions?
If you want, you have them. That's okay.
Oh, always. You mentioned about 2 terabytes and then more data. Does that all sit on one server? Okay, so it can, that much data, it can still just interact with one server. You don't need to split it into multiple servers.
No, we have it sitting on one. We have it just sitting
Yay.
on one server. Yeah.
I mean, if it
seems
can,
to-
then yay.
I mean, we'll see when we ramp up the data size if we have performance issues, but
Yeah, I was wondering if you had to get into data sharding or anything like that. That doesn't sound like it.
I mean, it's multiple disks, but
But still one server.
Yeah.
I meant splitting the multiple servers kind of thing. And I was wondering if it got complicated.
yeah.
So how do you expect this whole system to change, maybe in the future when radio IDs are mandated on all vehicles?
If that happens.
So, which it may well. Does that mean that we can read the radio IDs?
Yeah, will the system be more accurate, you think?
Where each car has an ID that can be identified and then goes back to the, are they readable on the side of the road or they're just?
Well, I think one of the motivations for that idea is for insurance companies to measure people's speeds.
Okay. So my answer to that is actually I think it depends on how the data is made available or not. So a lot of the data we get, it comes from the public agencies and they all make their data publicly available and so we can get that data. Companies like Inrix don't make their data available or they sell it for huge amounts of money. So if that's for insurance companies and it's fed back to the car manufacturers and back to the insurance companies, we may not have access to that data. But if you have a radio ID and a GPS system, you can kind of probably do what Inrix does and track vehicle locations and travel times. But a lot of that's already being done, so.
What percentage of vehicles do you think, do you know that you cover with by reading?
Bluetooth?
Yeah.
So Bluetooth reading we get, it's going up. It was in the single digits and it's probably up into the double digits now. It's also been found that if you have, that's also plenty. You don't need to capture 100%. If you capture 10% of the cars, you get really accurate travel times. So you don't need you don't need to capture anywhere near 100% of the vehicles to get accurate readings. Yeah.
Seems like before the wired systems with all the networks to pick up that data, unless it's a really longer distance, just the stations they have over the intersection now that reads the license plates, that are starting to be in a lot of places.
Yeah, so people are starting to put those in.
Yeah, I
Nothing
mean,
here
that-
yet.
That right
but-
there gives you the tracking information from one to the other, and
Right.
sitting right there on the intersection, as opposed to another system.
Right. So, I mean, it's all a question of whether the Bluetooth or the radio ID. I think will sort out over time. Other questions?
I'm always kind of curious, on the freeway, they have like these posts and it goes over like this, and then there's those two things that kind of sit over both lanes and you look down, and I was kind of figured they just like read the top of the trucks or something.
The way in motion stuff?
Yeah.
Yeah, so that's another set of data set that, so when you're driving on the highway and you see those things over your head, so there's two parts. There's a piece that's over the head, and then right along, and I can't remember if it's right before or right after, there's also a scale in the road. So there's a plate that you drive over that weighs your vehicle.
They're always right next to way stations.
So they're right next, so it's way in motion. And so trucks have a limit, and they have a permit, and they have a special limit associated with their permit. So truckers can buy a little RFID thing to put in their truck. You don't have to, but you can buy an RFID thing to put in your truck. You go into the reader reads your RFID number, sends it to the database at ODOT, gets your weight back, compares it to the weight on the scale that you drove over, and if you're within a certain percentage of your maximum weight, then you're given a signal that says you need to go to the weigh station. If you're well under your maximum weight, then it flashes you a green light in your truck and tells you you can go on without being weighed. So, what?
It tells them right there on the
So it
spot.
tells them right there on the spot. So it has like a quarter mile between when they go under the reader and when they get a red light or a green light telling them either go in the weigh station or go.
They're driving at speed when they go through.
Yeah. You drive right under them. You go, like, there's one like 20 miles south on I-5, and it's this, you drive, and there's something, it looks like a little gauntlet goes up, and there's two little things up on the gauntlet. It's fairly small, and yeah, they're driving at 60 miles an hour. So that's why, if you're close to weight, they bring you into the weigh station and give you like a slow speed or a static weighing. What it effectively does is it allows the trucks that are empty or mostly empty to bypass the weigh station. But trucks that are full and close to their limit go into the weigh station. So, yeah, but I always thought it was pretty cool that they could read it at 65 miles an hour and send it to the database and get the thing back and give them a signal within, a quarter of a mile.
Well, you acquire a lot of information. How is the public safety in there?
How is the,
Privacy or?
Privacy, yes.
so I try to avoid any data that's privacy sensitive in the database. So the Bluetooth data, we get in truncated MAC addresses so that it's just the end of your MAC address. It's enough data there so that we can match effectively, but it can't be tracked back to a person. The weigh in motion data, again, that could be identified with a truck, but we get it at a point where we can't track it back to any individual truck. So we just try and avoid any privacy sensitive information in the database.
But that's you doing it that way, as opposed to other people may not do it that way. Yeah.
Well, I mean, like it's part me, but it's also the people giving me the data. The weigh in motion folks don't want to give you any type of data.
So the data you already get is scrubbed before you get it.
And I specifically like it to be scrubbed before I get it so that we just don't have to deal with that issue. So. Right. Okay.
Thank you very much.
All right, thanks a lot.